Okay, so quick reminder. I'll remind you at the beginning of the lecture, at least for a few weeks here. On my phone, I'll be on the lecture channel in Discord. When the lectures are, when there's a lot of content and stuff, it's hard to keep an eye on it, but I'll do my best. And we should always have a TA. Nicholas is here today, so he'll be able to watch the chat and answer your questions in chat as you have them. And if there's something that he can't answer, he should be flagging me down and being like, yo, Jesse, this needs your attention. And then I can answer it. Okay, so we're starting content today. Who's ready? We're going to cover Scala. And I got to warn you right away, Scala is going to come and go very quickly. We don't have much time to introduce the language itself. In fact, it's 4 lectures, which is up from, we started at 2 a few semesters ago, and that wasn't enough. Upped it to 3 last semester, that wasn't enough, so 4. So hopefully it'll go a little bit slower, but I just want to warn you that it does go quick. You have to be ready to learn this language quick. And then next Friday, we'll introduce, let me just double check just to make sure I don't say the wrong thing. Next Friday, we'll introduce our first CSE 116 topic of unit testing. Yes.
Never mind.
So next Friday, 116, brand new 116 concepts will start. For the next 4 lectures, we're going to cover 115 concepts, but in Scala. And we're going to really rip through modules 1 and 2, really in 2 days, and then get on with the rest of the stuff. So Scala, let's talk about this. Most of what we talk about in these Scala lectures is syntax. Remember from day 1, from all the way 2 days ago, I do expect you to understand the concepts already. You already wrote the concepts in Python and JavaScript, or if you're a transfer student from Java or C++ or whatever you learned for those basic concepts. I expect you to understand those concepts, loops, conditionals, variables, etc. And I'm going to go over the syntax of how to do that in Scala. There is one exception. There are strict types in Scala, and you'll see what I mean as we get into this. So that is kind of a new concept that hits you right away. So let's get into it and talk about how to write programs in Scala. And another quick reminder, the lectures, the 2 early lectures are taught by Paul, the 2 afternoon lectures are taught by myself. When Paul does his lectures, and they're all available on UB Learns, we unfortunately lost Monday's lectures due to 3 different reasons that all had to line up to make us lose all 4 lectures. But we lost Monday's lectures, but today's lectures, you should have 2 available on UB Learns already, and then the 2 that I'm doing this one, and then right after this should be available. The reason I say that is my teaching style is mostly going to be through slides, and I'm going to cover the concepts. And then at the end of lectures, as much time as there is left, I like to go into IntelliJ and do some live coding. Paul is about the opposite of that. He'll spend most of his time in IntelliJ doing live coding. So if that style just gels with you better, check out Paul's lectures, check out those videos, and see how he does the live coding. So with that, let's get on with it. Here's your first Scala program. Hello, Scala. This program will just print Hello Scala to the screen. And right away, you should notice why we like to start you off with Python. In Python, this program is just print Hello Python. That's it. Nothing else. That's it. With Scala, right away, and the same is true for Java, for any of you who had Java in high school, there's quite a bit of overhead already. So let's take a look at our first program, parse this apart, and take a look at what each piece is doing. So first, this package declaration. Now, in most cases, for our cases in this class especially, and what you should be doing, this package declaration is going to match the directory structure of where this file is located. So if you take a look at the examples repo, there's going to be a directory structure. There's going to be an src directory. That stands for source. And that's where all your source code goes. Whenever we write code, technically it's called source code. So src, that's where all of your code goes. And then in that directory, there's a directory or folder named LO1 program execution. And inside that directory, there's a subdirectory called Scala. So the package declaration is mirroring the directory structure of where to find this, this file. And that directory structure, it makes sense if you open the repo that it's one directory for each of the learning objectives, and then for each of that I organize the lecture examples into subdirectories. Like this is just intro to Scala, Scala is the directory. So the package declaration, you can think of that as the directory of where this file is located. Next, we have to declare an object. Everything in Scala is either going to be in an object or, well, I can't really say that, but everything, most of the things we'll see are in an object or later on a class. This is the top level container of where all our code can go. In Scala, you can't just write code wherever you want. Your code has to, at least for these first 2 weeks, be contained in an object. So we're going to declare an object. We're going to name it hello. And the name of that object should match the name of your file. So if we put the package declaration and the object name together, we have a file in src LO1 program execution Scala in this directory named hello.scala. So, and vice versa. If you're in a directory structure and you find a file called hello Scala in that directory, when you open that, you should expect the package declaration and object name to match that directory structure and file name that you have. An object essentially is a container that can store our variables and our functions. And when our functions are inside an object, we call them methods. Just a little vocabulary. So when I say methods, if you think functions, I'm not going to get mad at you. But I will say methods because when our functions are in an object, we just call them methods. Don't ask. It's just extra verbiage that we have to learn. There is a technical difference, but I think we should just call them functions, but I'm losing that battle. Inside our object, we can define our methods. And there's one very special type of method. We're going to talk about, the next example is going to talk about how to define methods, what all of these pieces mean. But for a very special method named the main method, it'll be structured exactly like this. It'll say def main args array of strings unit. If you have a method that has that exact signature, that's going to be your main method. The main method is our way of telling Scala, this is where my program starts. Every program is going to start with a main method. And then in the main method, we might call other methods. We might define other methods like we will in the next example. But the main method is where the program starts. If you don't want to think about what all of this means quite yet, that's fine. But you would have to have a signature exactly like that. Named method named main, takes an array of strings, returns unit. If you have all of that, if I can handle this, all of this, whatever you put inside those braces, that's going to be what actually happens when your program runs, which in our case is just printing hello Scala to the screen. Print ln instead of print if you're used to Python. The ln means print line, which means there's going to be a new line character at the end of that, whatever's printed. So this will print hello Scala, and then insert a new line character. In Python, if you just do print, it will print the new line character as well. So it's the same thing as Python's print. Yes? Unit. Unit means that this method doesn't have a return value. That I promise that'll make more sense when we get into that content. I think you have to wait till Fridays to fully understand that. But that's the shorthand. If you're used to Java, it's the same as returning void. But unit just means this method, we don't call this for any return value. Like a method like math.absoluteValue, you're calling that because it's going to return a number, which is the absolute value of the input. With this main method, we don't care about any return value. So we say this returns unit or this returns nothing. And that's your first example. Any other questions on our hello world example in Scala? Like I said, it's mostly just new syntax. But that's the start of it. This is the start of Scala syntax. But but no new concept. You've printed things to the screen before. You should be pros at that. This is just how you do it in Scala. Can we find in-class examples like this in the CSE 116 examples project? Yes, yes, you can. You can find this exact example in there. So if you go to the, excellent question. So you go to the examples repo, you go to that GitHub repo, the link, I think it's the second link on the course website, and you'll find all the files there. Go to that directory, src, the source directory, go to LO1 program execution, go to Scala, and then open hello.scala. It'll be this exact example. The examples you see in the slides should, on occasion I make a mistake, but should all be in that examples repo. And the code will be cut and paste from that repo. So it should be the exact code that you're looking at on the slide is the exact code that you have access to in that repo. That should be true for any example I show on the projector. All right, if there are no more questions on that one, let's keep going. Let's learn some more Scala. Okay, here's our second program. Everybody knows what it does, right? Can we move on? Third program. No, we're going to spend a long time on this. So I want to talk about quite a few things. Of course, I'm rolling quite a bit into this one example. The two big things we're going to talk about, declaring variables, variables with types, defining methods other than the main method, input types, and output types. We got quite a bit rolled in here. You can use Community Edition. Community Edition is fine. So there's two different versions of IntelliJ, Community and Ultimate. Community is fine. It'll get you through the course. It'll have everything you need. Ultimate has some more features that you may or may not care about. But Ultimate is free with an educational license. Since you have an email address that ends in .edu, you can sign up for a license, get it for free, and get the Ultimate Edition for free. Otherwise, Community Edition is free, and Ultimate Edition you usually have to pay for. But for .edu email addresses, free. So, I mean, why not? Why not get the more features? But if you don't want to, Community Edition is fine. Okay. Let's define our first method other than that main method that I just kind of said, cut and paste this, blah, blah. All right, let's define our first method for real. Methods are declared using the def keyword, similar to Python. For some reason, my brain's like, are you sure? Yeah, it's def in Python, right? Def in Python, function in JavaScript. So Scala borrows the keyword from Python. Def means I'm about to define a method. Next is the name. No surprises here. You've seen that 100 times. Def, whatever the name of your method is. And then after that, your parameter list. Here's where we're going to start seeing our first difference. The parameter list, just like in your other languages, we're going to name each parameter. I have one parameter here, and I name it input. Nothing new there, but then we have a colon and then double on this thing. So in Scala, and many languages, many of the languages that you'll see in your career moving forward, you have to declare your types for certain variables. One variable that you have to declare types on every single time are method parameters. Your method parameters have to have a type. So this isn't just saying this method multiplied by 2 takes one parameter. It's saying it takes one parameter, and that parameter has to be a double. If you call this method with anything that's not a double, with some exceptions, I have to add caveats there. If you call it with something that's not a double, your program will not run. You'll get a compiler error, which will be a new thing you'll see this semester. Assuming you took 115 here and that was your first programming. So you have to define your type. Input of type double. So I have to call this method. When I call it, I'm going to give it a value that is a double. If I give it a string, for example, my program won't even run. We'll get what's called a compiler error. It will not run. You'll get an error. The IntelliJ will start yelling at you. Scala will yell at you. Can't do it. So your inputs have to have a defined type. Every parameter to a method has to have its type defined. And we do that, the syntax, separate your name, colon, type. Name, colon, type. We also have to have a return type on every method. So after the parameter list, after your closing paren, you're going to have another colon, which tells Scala, hey, I'm about to tell you the type, the return type of this method. And that's going to be the type of the value that's, I'm just repeating what I said, the type of the value that's returned from the method. What are we going to get back? When we call this method, what's the type that we're going to get back from that method? And in this case, I'm going to say it's a double. I want to return a double from this method. When I type that and I tell Scala this method returns a double, Scala will take me very seriously. If I write this whole method and I don't return a double, Scala's going to be like, WTF, man. You told me you were going to return a double. You never returned a double. What's going on? And you're going to get an error that says type mismatch, expected double, but got, usually it'll say any, got something that's not a double. That means you said you were going to return a double, but you never returned a double. Never made good on your promise. So if you say you're returning a double, you are returning a double. And Scala will force you to put the return type. If you don't put the return type, it actually won't yell at you. But going back to our previous conversation, it'll assume that it returns unit, which means nothing, and you'll never get your return value out of the method. So if you're trying to multiply something by 2 and you're calling this method, but you forget your return type, you're never going to get your actual return value because you didn't tell it you were returning a double. And now, what does a method return? No matter what language you're coming from, you're probably noticing the stark absence of the keyword return. Return, the keyword, does actually exist in Scala. It's allowed, you can use it, but it's discouraged. First of all, it's optional. It's actually discouraged. The Scala community, just the groups of Scala developers decided, we don't like return statements. There are good reasons for that. There are good compiler optimization reasons for that. Your code is going to be more performant if you don't use return statements. But whatever the reason, this is all we need to know. It's discouraged and optional. So I won't show you return statements except one specific example I have where it just made my life a lot easier. Later in the semester, we'll see that. But usually, I won't show you return statements, and I shouldn't really see return statements in your code. I won't get mad at you if you have return statements, but it's just part of the Scala community. Scala developers don't like return statements. Instead, what's returned from a Scala method is the last expression that's evaluated as the method executes. So I never told Scala explicitly what's returned, but I only have one expression in this method, the input times 2. So when that expression is evaluated, it's going to resolve to whatever input is times 2. In our full example, 7 times 2 resolves to 14. Since both types are doubles, I saw the question in chat, since both types are doubles, it will infer that the return, that it should resolve to a double. So this will resolve to a double, and then return 14. Since there's nothing left to execute, we hit the closing brace. Nothing left to do. So whatever that last expression that was evaluated, that's what's going to be returned. That's the value we get out of this call. And there are a lot of implications of that. In the next example, we'll see an implication of that. Now, variables. To declare a variable, there are 2 keywords we can use. I'm using var right now. In the next example, I'll show you val and explain what that is. Var, short for variable, give me a variable. Hey, Scala, give me a variable, name it x. And then when we create a variable, we should define its type. So I'm going to declare its type, same syntax we used for parameters, colon, and then this x, I want it to be of type double. So I'm going to say I'm creating a variable named x of type double, and then the rest, you've seen this plenty of times, and assign it the value 7.0. And I got myself a variable. Var value means var for variable means the value stored in the variable can change. It is a variable. It does vary. Next, I'm going to declare another variable named result. And here I don't say my type. I don't specify my type. In most of my lecture examples, I'm going to specify the type just to be very clear about what the types are of all my variables. But sometimes I won't. And we can get away with that in most cases. In most cases, I shouldn't say in most cases, but in some cases, we don't have to declare our types. I always recommend it. If you declare your types, you're not going to be surprised by the types changing and not being what you expect. But here, I don't declare my type. And Scala is able to infer the type of that variable based on what it's being assigned. So what it's being assigned is the return value of multiplied by 2. And Scala knows exactly what type that's going to be because we told it. It's going to be a double. So since that method can only ever, in its entire life, ever return a double, Scala's going to be like, I got you. I get that result's going to be a double. It can't be anything else. So Scala will be able to infer. And Scala does work for us quite a bit in this sense. It's going to figure things out for us. If there's only one possible answer, it's going to know that, hey, that's the answer. Result has to be a double. It can't be anything else because it's being assigned the return value of a method that returns a double. Like I said, in most lecture examples, I would still put result of type double just to be clear about what I'm doing. We're still learning this stuff, so I like to be explicit about everything. But Scala will help us out in a lot of cases. Same up here. It's inferring that this is going to resolve to a double and make sure that it returns a double. And since it's a double times a double, it's going to be fine. Yeah, there are pre-existing types. In Friday's lecture, we'll go over the common types that we'll use throughout the semester. All right, any other questions on this example? Yes?
Why are there parameters for the main function?
The array of strings. So there is a parameter for the main method. We won't use this in CSE 116, but this is where your command line arguments would go. If you're calling your method from the command line, if you've been in a terminal before, a Linux terminal or command or PowerShell in Windows, you can call your program and then give it additional parameters after that. You can say run this program and then give it more parameters. That's where those parameters will go. Yes?
More of a styling question. In JavaScript, I like to return my top brace just for a reason I like the way. Can I do that in Scala? Is there any reason why I can't do that?
Oh, you like this brace down here?
Yeah.
Oh.
Yeah, I know.
How does it feel to be wrong, though? No, I'm not going to get into that battle. Yes, you can. You can do that. So this is not like. Sorry about that, by the way. This is not like Python where white space matters. White space doesn't matter in Scala. You can throw things all over the place. It'll be fine. Indentation. You got your indentation all over the place too. Now I get the debate. And I see the argument that if you put your braces down here, it's more clear where everything starts and ends. I understand the argument. I think it's just that I was shown this way when I first started learning coding, and it's just too hard to break that habit. But I see the benefits of doing it the other way. Any other questions? Was there a hand up? I thought I saw another hand. Moving on then. Okay, let's throw conditionals in here and talk about a little bit more complex example. Though not too much more. Not too bad still. So let's take a look at this program. I'll just briefly go through what it should do. I'm pretty confident, though, that even if you've never seen Scala in your life, you could probably look at this program and figure out what it does. I would assume that you're competent enough at deducing what's going on here. But I'll go through it quickly, and then we'll go step by step to see what Scala is doing specifically to the language in this program. So we're calling a method compute size 3 times with 3 different inputs. We have 2 cutoff boundaries for whether the input number was large, small, or medium. When we call it with 70, we should return large and print it to the screen. 50 should be medium, and 10 should be small. So that's what we want to do. This program will print out large, medium, small. So let's see exactly how Scala is doing that and some of the traps that you might fall into doing something like this. Okay, first, we're using a different keyword to declare our variables. And in fact, these aren't even variables. These are values. VAL, val for value. This is the same as a const in JavaScript. These cannot change. It will be the same value for its entire life. A variable, var, can change values. A value, val, can never change its value. Large, the value large of type double will always have the value 60 forever. If we try to change it, Scala's going to yell at us and it's not going to run our code. So values, two values of type double with values 60 and 30 that can never, ever, ever, ever change. Then we have a big conditional. So the syntax for the conditional, this is just like JavaScript. This is probably valid JavaScript for the most part anyway. I don't have much to say about the conditional. You've seen if statements before. You've seen this specific syntax before. If the input is larger than large, run that block of code. Else if the input is larger or greater than or equal to medium, run that next block of code. If both of those are false, run the next block of code. What I want to talk about is how we're returning things. So this method will return either large, medium, or small, depending on the conditional. So depending on which conditionals, which Boolean statements are true or false, something different is going to be returned because the path through this method is going to be different, and the last expression that's evaluated is going to be different based on those conditions. So when the input is 70, we're going to run this line of code, this expression, which is an assignment expression, which happens to return unit. This, which is an assignment expression, which returns unit. Then we're going to have 70 greater than or equal to 60, which is true. We're going to run this block of code, evaluate this expression, which is a string literal. It just resolves to its value. So this expression resolves to the string large. We hit a closing brace. We skip the rest of the else statement. We hit the closing brace. The method ends. And the last expression that was evaluated was the string literal large. That's what's returned. The last expression that's evaluated. So when the last statement in the program is an if statement with, in our case, an if, an else if, and an else, that conditional is going to determine what the last expression that's evaluated happens to be. So the conditional is going to decide our return value because my conditional is the last statement in the program. And that statement contains 3 different expressions, and only one of those expressions is going to be evaluated. So the last expression that's evaluated, this goes back to those first few weeks of 115, which might have been a distant memory. It's expressions and statements is one of those things you learn once and just kind of intuitive after a while. Scala is going to make you remember the specifics of those things. These expressions, only one of these 3 is going to be evaluated at the end of, by the end of this method. If you're trying to use the same trick and you have a conditional as the last statement in your method, which is going to determine which is the last expression that's evaluated, there are a few things to watch out for. One, make sure you don't put anything after that conditional unless it's meant to control your return value. So if I put anything after this, my large, medium, small is not going to be the last expression that's evaluated. It's going to be whatever I put after that conditional, and Scala is going to yell at me, or I'm just not going to get the right return value. And you always have to return the return type. I return a string. I told Scala I return a string. That's a contract. That's firm, concrete. I made a contract with Scala and signed it in blood. Scala will hold me to that and make sure I return a string. Even if we know we're returning a string, Scala still might not be happy. And let me explain what I mean. If instead of an else here, I put else if input less than medium, then small. Program would have the same effect, except for some really, some edge cases. Program would have the same effect, but Scala would be mad at me because I'm not always returning a string. If I put else if input less than medium right here, Scala is going to say you're not always returning a string. Your return type is any. Expected string got any. It's going to be really mad at me. That's because Scala doesn't know any better. It's going to say it's technically possible for this to be false, for this to be false, and for input less than medium to also be false. And if all three are false, we never evaluated an expression that resolves to a string. Therefore, we did not return a string. If you're returning a value with a conditional like this, you got to have that else statement. If you don't have an else, there's no guarantee that one of your blocks of code will be executed. There's no guarantee that you're going to return anything. So make sure you have an else if you're using this, this setup. The last expression that's evaluated, no matter what path your code takes through your conditionals and through your loops, the last expression always has to match the return type. Always has to resolve to a value of the return type. All right, let's do this. Lecture question. We're working on the, so go to Autolab, the Wednesday question. You should be able to see it. It should be up there. We're playing around with how to do the lecture questions. Obviously, it was super slow and laggy on Monday. It should be pretty performant right now, but that's because I removed the auto grader. So you're not going to see your grade until later today. I'm going to process everything. But it should be fast, hopefully. If it's not fast right now, then we got big problems. So if anybody's having issues submitting, make sure you let me know, because then I got a lot of work to do then. That would definitely be my fault. I'd have to fix something big. Oh, good question, Antair. So the next thing I'm going to do is go to IntelliJ and do examples. That's a good one to try. I was actually thinking that as I was saying this. I'm like, I think I can do that. We'll find out together and learn if we can get away with that. If we have a string before the conditional that just says like large, and then the conditional with no else. I want to say we should be able to get away with that. But we'll see how Scala does it. Everything go to the submissions? It should be pretty instant. But no matter how many times you refresh that results page, you're never going to get a score there because there's no auto grader. So don't just mash refresh. You're never going to see anything. Until, well, not for a few hours at least. And once everything's set up, I'll like shut off the question and then go over answers. But is everyone good? Everyone submit? Anybody have issues? If no one's complaining, that's a good thing. I like it. And this first week, especially before add drop anyway, I mean, I don't plan on not giving you credit for the lecture questions. If somebody adds the course next Tuesday, I'm going to give them credit for these questions anyway. So, so what's the answer to this one? C. All right. So normally I would shut off the question. You wouldn't be able to get credit anymore, and then we'll go over the answer. Today, I mean, if you submitted the wrong answer, I'll just commit to it right now. I'll go back and give you the credit as long as you submitted. And just for today, because we said the answer, somebody who sat there and had no idea what was going on and then heard the answer and then did it, would get credit and you wouldn't. That wouldn't be fair. Anyway, it's C. The value is the last expression that's evaluated. I want to make sure if you get nothing else out of this lecture, it should be that, which is what the lecture question's purpose is to make sure you get the most important point. That's one thing that's just pretty different in Scala that you haven't seen in really any other language. I'm not aware of another language that does that. I'm sure there are that I just don't know, but the last expression that's evaluated. All right, so let's go into IntelliJ and do some examples. And we've got a good amount of time here. The first thing I want to do is take a look at this code. This is the code that we saw just now. It's in the examples repo. You can see that I have a source directory. By the way, lab next week is going to walk you through getting to this point where you have all the examples in your in IntelliJ and have IntelliJ set up with the right versions of Java and Scala. So if you're not able to do that before next week's lab, the TAs are going to walk you through that. The lab document is posted for that on the course website. So if you want to, if those links that I put on the course schedule aren't doing it for you, check out that lab document. It's right under where it says week 2, right underneath that, it tells you what the lab is for that week. And that link, that one is a link to the document. So we have our example. Once we have any code that you want to run, we can go to the file that you want to run. In the directory, LO1 program execution.scala matches our directory, LO1 program execution Scala, and then conditional, our object name. We can right-click on that and hit the run button. And that's going to run our program, and we should see that large, medium, small. This is something you haven't seen much in Python and JavaScript. This is our code compiling. So before Scala runs, it actually has to be compiled, which means it's rewritten in a different language, and then that language is ran. So if it takes a little while from when you hit go to when your code actually runs, that's your compilation time. So large, medium, small, and we're good. So let's play around with this. First, if I do else if input less than medium. Now we all know that one of these is going to be executed in most cases. The exception would be if input was null, which is part of why Scala should yell at us. With null, none of those conditions would be true and we'd be in trouble. But if you do give it a valid double, it's always going to return a string, but we're going to get this error. Let me run it. This button up here will always run the last file that you ran. So if you're running a bunch of different files and this isn't running the right one, it's because it's always running the last one that you ran. So we get type mismatch, found unit or nothing, required string. If you see that, watch your return types. Make sure the last expression that's evaluated always matches the return type. In this case, if the input is null, Scala's right. This doesn't always return a string. So let's go to the question in chat. If we put large right here, or maybe error, will it calm down? It looks like no, Scala's not okay with that. I was hoping that would work too. I was rooting for that one. So even though we always do get the last expression evaluated is a string, Scala's not happy with that. It's not. I never tried that. I got, apparently for good reason it wouldn't work. But that won't work. If we wanted to set things up like this, I would add an else and do error, and this will work for us. Now, even if we do an input of null, everything's fine, everything works. Hold on, we'll get there. Now I'm missing a parenthesis. How did that not work? How did none not work? You know what? Maybe Scala is just full of crap. It does always return a string, Scala. Damn it. Scala's wrong. All right. Well, I'm sure there's something. No. I'm not gonna waste more time trying. But I'm sure there is an input. I'm not coming up with it. None should work, but unless it's nothing, I'll give it one more try. Is it nothing? No. Done messing with it. Okay, so next thing I want to show you, how to set up a project from scratch. Now, a lot of the times, I guess all of the time, you're going, in this class, you're going to clone a repo, you'll clone the project repo, and then edit the code that you cloned, and then submit that. So you clone a repo to get the starter code. There'll be some code available before you start working, and then work on that. But I do want to show you how to start a project from scratch if you want to start your own projects. Plus, Paul is doing this in all of his lectures. He starts a lot of lecture examples from scratch. So I want to at least show you. So you're going to go to File, New, Project. No surprise there. And then when you get this pop-up, you'll want to select Scala. If you didn't install the Scala plugin, you won't have that option Scala. You might have to install the plugin and then restart the IDE, restart IntelliJ. When you select Scala, if you want, you have other choices here, but if you want your project structure to mirror the examples repo and mirror the project code, the starter code, select IDEA project. Select Scala, IDEA, next. Name your project. I think Untitled one. Oh, I'll name it something meaningful. You can name it whatever you want. I'm going to choose the wrong SDK, and I have the wrong JDK here. So I want to go through how to fix those when you have the wrong versions of things. What we'll talk about in lab, what we have on Piazza, what we have in several places. But I want to give you a live example too, make sure we get this in lecture. So I've started a new project. I have a source directory. I can create packages. I can go right-click, so I'm right-clicking on this, going to New. Then I can create new Scala Objects too. We're not dealing with classes yet, not till week 4. So I'll select Object, and I'll name it Lecture, I guess. That's going to set up some of the structure for me. You're going to learn that IntelliJ does quite a bit for you. So when you saw that first Hello World file, that first Hello World program, quite a bit of that is done for you. Even all that main method. It's def, main, args, of type, array, of string. It's 2022. We're not memorizing that shit. We're going to type main and hit enter, and it's going to give it all for us. Just type main, enter, done. Print line. Hi, and then you can either click this arrow, or right-click and hit run, and it's going to run your program. After you run it once, this will run whatever the last thing you ran was. So now I can use this arrow if I keep working in the same file. But if I create a new file with a different main method, I got to go right-click that or click one of the go buttons in that file. Now I have the wrong, this works, of course, but I have the wrong versions of the JDK and SDK according to the class. I'm not using the class official stuff. So if I work on this and then submit to Autolab, Autolab might not be happy. So to fix that in 3 minutes, I'm going to go to File, Project Structure.
I love you, right?
Why is this so scrunched over? Anyway. It's hard to read it. I'm going to go to Libraries. I'm going to remove, I actually have my JDK 15 right here. I'm going to remove that too, just to show you if it's really messed up. I'm going to click this Add an SDK. I'm going to download a JDK. Now, one of the links I showed you goes to the Oracle website and downloads the official Oracle JDK. There are other JDKs. Oh, this is actually giving me an option for Oracle. Oracle, I'll go on a super mini rant here. Oracle loves doing the lawyer thing, so sometimes you're allowed to download it through third-party software. Sometimes they say you have to go to their website and agree to their terms and everything. Apparently today they're letting us download it right here. So the Oracle JDK or the Azul Zulu, this is what we used last semester. It works fine. These other ones might also work fine, may or may not. But I'll get the Oracle one, download it. And then once that's done downloading, I'm going to have my JDK set up. JDK 15 or higher will work for this course. In Autolab, it will be 15. So if you're worried about any small version differences, 15 is going to be the same that's in Autolab. And when you submit to Autolab, the first thing the grading script prints out is the version of Scala and Java that it's running. So if you want to match those exact versions, I believe it's Scala 2.13.4 and JDK 15. If you want to make sure you're matching exactly what's in Autolab and you never get surprises. So we have our JDK set up. Let me remove my Scala SDKs to show you. I'm going to add. Now I'm one below. It's hard to see, but I'm in global libraries. I'm going to click the plus, Scala SDK. I'm going to choose the latest version. I want 2.13 and the latest version of that, or 13.4 if you want to match Autolab. I don't see it here, so I'm going to go to download. 2.13.8, cool. And once it downloads, I can select it, and then I'm running the right version of Scala for this course. Come on. Come on. Anyway, you have to trust me that that works. And then everything's set up, and then I have the right versions of everything for the course. So with that, I'll see everyone Friday. Have a great day.